Are you bothered? Now, we are going to continue the lesson. We have started yesterday the chapter carbon, right? So, what are the different sources of carbon? Coke is source, charcoal is source, graphite is source. These are purest form. But impure form also it is found. It is found in compounds also. Carbonates, bicarbonates, carbohydrate, protein, vitamin, petroleum. These all are the sources of what are you drinking there, Kade? Come this side, come here. Sneha, come down front. Come here. Is your breakfast time? Come here. And two experiments or activities were given as work to you. So you have done or not, I'll check later. Now we have just discussed some things about carbon. What is here? At first, nature of carbon. What are we going to discuss? Nature of carbon. So first we have to identify whether carbon is metal or non-metal. So electronic configuration of carbon is twofold. In first orbit there are 2 electrons. In second orbit there are 4 electrons. One thing you have to keep in mind, in the valence shell, in the outermost orbit, if there are 4 or more than 4 number of electrons, that is non-metal. If there is 1, if there is 2, if there is 3, that is metal. More than that, that is non-metal. What do you say? What do you think about carbon? Is it metal or non-metal? Non-metal, here are 4 electrons. And it belongs to group 14 in periodic table. Group 14 or 4A. And in second period, this is the position in periodic table. In periodic table, it lies in group 14. Underline, you can underline the book also. And period second. So atomic number is 6, atomic weight is 12. 6 proton, 6 electron, 6 neutron. And we know the orbital electronic configuration of carbon is 1s2, 2s2, 2p2. This is p block element. What is this? Because 1s2, it is filled, 2s2 also filled, and valence orbital is, or subshell is p, that's why this is p block element. And in its valence shell, outermost shell, there are 4 electrons. So, what does it do? Can it lose all 4 electrons? It cannot. It cannot because it is non-metal. Non-metal cannot lose electrons. Non-metal has got 2 properties. One is, it may share electrons or it may gain electrons. May share or gain. Right? Mainly what does it do? It shares electrons. Sharing. So if the bond is made by sharing, that bond is called, what is that bond called? Covalent bond. So in most of the cases, it forms which bond? Covalent bond. Right? But if it reacts with metal, then it forms electrovalent bond. And carbon has mainly 2 properties. We have to remember. What are the 2 properties of carbon? Tetravalency and catenation. What is that? Tetravalency and catenation. Tetra, what is the meaning of tetra? Tetra means 4. Mono is 1, bi is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, deca is 8, duodeca is 12. In that way we have to remember. 11, there is the word, but right now I forgot. Yeah, definitely, why not? They have given like that, right? You know, we all are single child. I think nobody is here twin, right? If one child is born, that is single child. If two children are born, then what are they called? Twins. If three are born, triplet. Triplet, T-R-I-P-L-E-T. Four are from quadruplet, right? Right. Quadruplet. If five are from pentuplet. Some ladies, they have given birth to 5 children also. Some they have given 6. What is that? Hexuplet. One lady of Brazil, she has given birth to 10 children. Decuplet. She did know actually given birth means it was cesarean operation. By cesarean operation, it was successful activity. They have done. Okay. What are the two properties of carbon? Tetravalency and tetravalency. So tetra means what is that? 4. One thing you have to keep in mind, carbon is that element which can link with another carbon atom. Interesting. And can form a long chain. See? C. Yes or no? This is one property. And next one is, it can make 4 bonds. How many bonds? In different directions. See? This carbon can bond is making 1, 2, 3, 4 bonds here. This carbon 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It can share electrons and make bond. So there are 4 valence electrons. Valence electrons, how do you know? Or what do you mean by valence electron? The electrons which are present in outermost orbit, they are called valence electrons. There are 4. So it is capable of bonding with 4 other atoms. How many other atoms? 4. Let's check the example here. This carbon can bond with this carbon, this hydrogen. With 4 elements are there. Again, this carbon, if we take example, it can bond with this 1 carbon, 1 hydrogen, 1 carbon, 1 hydrogen, 4. 1 carbon can link with how many other atoms? 4. That is the unique nature of carbon. So, here is the definition of tetravalency. What is the definition? Property of a carbon atom to combine with the 4 atoms of other elements. How many atoms? 4 atoms of either. Means 1 carbon and other elements also. For example, if I give here this example, C, 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 hydrogen. With how many atoms it has linked together? 4 atoms. So this is called tetravalency. Because of this nature, carbon can form millions of compounds. So in the earth, there are maximum number of compounds which contain carbon. Yesterday I told you, if carbon is eliminated from the world, then very few compounds will be left. Right? What is the next thing? Catenation. What is the next one? Catenation. Look at it, children. What is this? Carbon. Earlier we discussed in tetravalency, carbon can link with how many atoms? 4 atoms, tetravalency. Next unit property is carbon can link with other carbons and form a long chain. In the world, there is only one element which can link with another same atom, that is carbon. That property is called, what do you call it? Catenation. What is the definition of catenation? You just take here, take unique property of a carbon to form bonds with other carbon atoms, giving rise to a long chain or branch chain molecule is called catenation. So, this is long chain. See, carbons are linked together, but That is straight chain of carbon, and this is branch chain of carbon. This property is called, what is called? Catenation. What is the definition of catenation? Say together. So, what are the two properties of carbon? Tetravalency and catenation. Tetravalency and catenation. If you have to give the example of catenation, then you can give this one. You can draw carbon, and so these are the bonds. What type of bonds are these? Covalent bond or electrovalent bond? Covalent bond. So, carbon compounds are maximum in number. So, there is separate branch of chemistry to study them. That branch is called, what is it called? Organic chemistry. Branch of chemistry that deals about compounds of carbon. Okay? Now, this is the diagram to show catenation. What is this? Catenation. Earlier, we saw one side yesterday. See here. One side, can you see? This one. What is this? Hello children, what is this? Carbon. Carbon exists in two forms. Crystalline form, they have geometrical shape. Amorphous form, powdery form. Diamond is carbon. Coal is also carbon. Is there a difference between diamond and coal or not?
Yes.
Graphite and diamond, both are carbon, but there are got differences. And fullerene. Carbon exists in two different forms. One is with geometrical shape, another with powdery shape. Means it doesn't have any fixed shape. When we heat, it is in powder. If it is heated, even though it contains some geometrical shape. So crystalline form and amorphous form. Three crystalline forms are here: diamond, graphite, and fullerene. Amorphous, four forms are there: coal, coke, charcoal, and lampblack. And here, charcoal are of three types. Yesterday we discussed. What are they? Sugar charcoal, wood charcoal, animal charcoal, or bone charcoal. Now we are discussing about allotropes of carbon. So, I don't know, in your book diagram is there or somewhere else? Your diagram is somewhere else and then explanation is down, right? So it should be here. Allotropes of carbon. What do you mean by allotropes of carbon? Different forms of carbon. We mentioned their diamond, graphite, fullerene, coal, coke, charcoal. These are different forms. Some are crystalline form, some are amorphous form. They are called allotropes. The different forms of carbon are called allotropes. Examples, what can you give? What are the examples of allotropes? Diamond, graphite, fullerene, coke, coal. Here is another heading. What is that? Allotropy. What is the definition of allotropy? Property of an element by virtue of which it can show many physical forms and have similar chemical properties. Physical forms are different, chemical properties are same. That existence is called, that property is called allotropy. And again, here is the definition of allotropes. What is that? The elements which exist in different forms having different physical properties and similar chemical properties, that is called allotropes. Only one element is found in with allotropes, that is carbon. Carbon is found in different forms, not other elements. We are talking about elements, right? So, okay. Just now, what did you discuss? Tell me. Number one, nature of carbon. What is the first one? Tetravalency. Next one, catenation. tetravalency means one atom of carbon can link with four other atoms, right? Catenation, carbon atoms can link together and form long chain. Next one, allotropes. Some elements they have got same chemical property but different physical structure. They are called allotropes. That property is called allotropy. Now at first let's discuss about diamond. What is this? Diamond. This is the structure of diamond. Here is carbon, 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 carbon. Everywhere is carbon on it. But they are linking differently. If you take this part, is it hexagonal or not? Are they hexagonal? So these all are hexagonal. There are 6 carbon atoms. So purest and densest form of carbon. Densest means its density is highest. The molecules are compactly packed. It is the hardest substance. Even iron also cannot cut it.
Diamond.
Yeah. That's it. To cut diamond, what is needed? Diamond. Diamond cuts diamond. So it is harder. What is the density? Density of a diamond? 3.52. Density of diamond is 3.52 means it is 3.52 times heavier than water. Okay? 3.52 times heavier than water. If you keep in water, does it sink or float?
Sink.
It sinks. But you have seen that wood charcoal. If you keep wood charcoal in water, does it sink or float? Both are carbon, yes or no?
Yes.
But density is same or different? Different. It is transparent to X-rays. It does not emit light, but when light falls on it, it glows. Yes or no? When light falls in one face, strikes, then total internal reflection takes place, and same light moves inside the diamond crystal, and little light comes out. That's why it seems glowing. Give it going in. Sorry. Transparent to X-ray. It is given here. It can. Okay. Why? Are you planning to swallow some diamond and go here and there? Sometimes people they do like that. So some mafias who do such type of illegal one. Some they hide inside their body also. They cut that part, stitch and what? Coming. And when they pass, I think they have got other detectors and they can find, oh, there is diamond. Yes. Take someone else. And check their body parts where there is stitch, open it. Interesting. It is bad conductor of heat and electricity. Bad conductor of heat and electricity. And when we burn it up to 800 to 900 degrees centigrade, it burns. And diamond bonds with oxygen. Hey, what are you writing this? Don't write down. Stand up. It bonds with oxygen. You come this side. And then forms carbon dioxide. Because diamond is carbon. Yes or no? Bonds and what forms? Carbon dioxide. That is very much lost. In that loss, diamond is cheaper or expensive substance?
Expensive.
It is quite expensive, right? Here are some uses of diamond. What is the first use? First use. Yeah, it is used in different type of jewelries, right? But last time I just went in the shop and asked, what is the cost? Small portion. Cost 60,000 rupees. And I said, thank you, bye bye, auntie. What to do? And that should be kept in gold. Gold ring with diamond gem near about 2 lakh rupees. I'll take highly return back. What is second use? What in glass and marble. Why? Because it is the hardest one. You can cut it easily. Right? Third one.
It is used to make
These make high quality thermometers. Thermometers are also made by US. And fourth one is used to make radiation proof windows of spacecraft. That spaceship, do they go in space army?
Yes, sir.
So their windows are made up of,
Diamond.
because diamond is transparent, some light must enter inside the diamond. Right? Okay, that is the discussion matter right now. So children, open your book, everybody. You read this nature of carbon to uses of diamond. Then I will give you some types. What are you copy master Adhikari?
Yesterday.
What yesterday's work you have to do at home? Yesterday's work you have to do at home or not? Now I'll check your yesterday's work. First of all, it's nature of carbon to usage of diamond. Okay? Yes, thank you.